Hi everyone. Again, welcome to the solution series of YouTube DPP machine learning. So let's start this question. So in this question, they are saying that some loss is given, but they have defined the loss as a piecewise function, which means they are saying that okay, the loss is this if this value is this or something like this. So basically, they are basically comparing the predicted value and the actual value, and then they are saying if the absolute value is greater than 2, then we will be having some loss. Otherwise, if the absolute value is less than or equal to 2, then they are saying let's just not have any loss. So this is the predicted one, right? So what you can do, you can easily find out the y cap for everyone. Like for example, for just I have the table for this 3, y cap is 6. For this is 10, and the real y is anyway given, right? This is 7. So the absolute difference between these two is 1. This is 2. This is 8, right? So we know the absolute difference. Now, if it is less than or equal to 2, then the total loss is 0. Otherwise the total loss is basically a square of minus 2 and then square. So basically if you do 8 minus 2 square, then you will be getting 6 square, which is 36. So that's why you will say the 36 is the loss here. Now what they're asking is the average loss over these 3 data points. So you can average it out, 0 plus 0 plus 0, 0 plus 0 plus 36 divided by 3. So it is coming out to be 12. So 12 is the correct answer here. So let's just see. Yeah, 12 is the correct answer, right? Now let's see the next question. This question is interesting. So here they are saying that in a least square regression, okay, which of the following must always be true for the fitted regression line. So by the way, here I think I forgot to mention that bias is used. Okay, bias is used basically, right? So they're given the error, and then based on the error they are asking that which of the following is true. So let me tell you one very interesting thing is this. See, suppose this is your this is your x and this is your y, and x and like y is not in the space of x. That's why you need to project this y, and that's why we need to have y cap. Okay, so this is y cap. So this is the error, which is y minus y cap. Okay, this is the error, y minus y cap. Now this error, okay, for every point, like there will be the error y minus y cap. So this error is basically you can say perpendicular. Okay, this error is perpendicular to columns of these are the columns of x, right? Now if you are using a bias, then the columns of x must be having ones, right? Which means the columns of x generally we write like this: 1 1 1, and then first column, then second column, then third column, like this, right? To cater the bias, right? To cater the bias. So basically this y minus y cap is perpendicular to columns of x. That's what I know, right? So let me make this diagram again probably, and I will prove this in two ways. This is a very interesting proof. Okay, so I will prove it in two ways. One of that y minus y cap is perpendicular to columns of x, right? And columns of x must be having 1. So y minus y cap is perpendicular. So I can say that y minus y cap is perpendicular to ones, right? I mean the columns, the column of ones. So which means if this vector, which is y minus y cap, is perpendicular to 1, so the dot product must be 0, right? Must be 0. So which means this is basically the let's suppose any column. Let's suppose u transpose or u transpose 1. Okay, or let's suppose u is basically, I mean to say u is perpendicular to 1, which means u transpose, okay, u1 u2 u3 u transpose, right? If these are the scalars, then let's not write like this. So u1 u2 u3, right? This is the u transpose into u transpose 1 must be 0, which means u1 plus u2 plus u3 must be 0, right? So similarly, if this vector, which is y minus y cap, right? So the first entry here will be yi minus yi cap. The second entry will be the first entry will be y1. I mean the entries will be in the I format. So first entry will be y1 minus y1 cap. The second entry will be y2 minus y2 cap. The third entry will be y3 minus y3 cap. So this vector is basically perpendicular to 1, right? So what does this mean? It basically means that summation of all yi's minus this yi cap must be 0, which means summation of all the errors must be 0. So yi minus yi cap Instead, if you want, you do not need to even open up this, right? You can write E1, E2, E3 instead of this. So this must be 0, which means summation of EIs must be 0, right? So see that this is EI only, right? So this vector, or this is vector E, which is every entry is basically EI. Okay, this is the E vector, error vector. So error vector is basically, you can say E1, E2, E3. E1 is by1 minus y1 cap, something like this, right? And E2 is something like this, right? Y2 minus y2 cap. So basically every of this entry here is, or you can say this vector is perpendicular to 1. So so summation of these, all the values will be basically 0. That's how you can prove it. Okay, so why it is perpendicular to 1? Because we have the bias. You can have the mathematical derivation also. So basically, if you say that you write the loss function like this, right? Loss in W and B, you write, let's suppose you have the bias also. So you write like this: yi minus W transpose xi plus B, right? This is your term, and then whole square. Okay, so this is summation over all the data points. Now, since you have bias, so you will be minimizing with respect to B also, and you will be minimizing with respect to W also. So let's just see what happens if you minimize with respect to B. So don't worry about the summation. Whenever you have the differentiation, okay, summation will be as it is. Summation is not an issue here. So 2, you will be writing 2, then yi minus again W transpose xi plus B, and then 2 will be here, and then I think some -1 or something will be there, but that doesn't matter. Okay, even if it is -1, it will go to 0. Okay, I think maybe the -1, because B is multiplied by -1, so you need to multiply by -1 also. That's fine. Okay, so from here this -1 will anyway go to 0, so let's not write it. So from here this 2 will also go to 0. So from here you can write something like this, that summation of yi minus W transpose xi plus B, okay, B, this whole thing equal to 0. And what is this? This is error only, right? This is error. I mean, this is bi cap and this is the error. So from here you can directly say summation of EIs must be 0, right? So if you differentiate with respect to B, since there is a bias, so you are getting this as a final answer. Which means if you have the bias term, then you can adjust in such a way that summation of all the errors must be 0. Which means geometrically you can look like this. Okay, you can have a look something like this, that if you have the bias with you, then let's suppose these are the few points where you want to fit the line, okay, in a linear regression. So if you are allowed to have the bias, then that will adjust in such a way, this bias will be adjusted in such a way that all the errors, like whatever is this, like something plus error, some minus error, okay, all the errors total all of these errors, if you just take the values, I mean signed values, okay, not the absolute value but the signed value of all of these errors, then summation of all of this is, let's suppose E3, this is let's suppose E5 or whatever, right? Summation of all of these errors will be 0. Okay, that is the magic of bias. Okay, if you are allowed to have bias. Understood? So this is very nice. I can say this is very nice question, and this gives you the 2 ways to prove it, that okay, since you have bias, then X must be having the ones. So basically you can say that error is perpendicular to ones. That's a very easy way. This is the one of the way. This is very easy way. You can also differentiate, and you can get to know, okay, because of the bias I'm getting this, right? So that's how you can prove it, that okay, summation of all the error terms is 0. This is really a nice question. I hope you like this question. Okay. Now let's go to the next question. This is easy question only. Here they are saying that if you are modifying this, in this model you are modifying the features to be 10x. So basically, if this is 10x, then obviously whatever is the solution here, I mean since it is a linear feature only, so the answer will not be changing. So to adjust the answer, so you can say this beta 1 will be in such a way that it must be same as theta 1x. I mean to say that this beta 1 will be basically 1 by 10, right? Just 1 by 10 theta. Okay, theta 1. I mean, whatever here answers you get. So cap means the final answer. Cap, we write cap. Cap means these are the answers after differentiating whatever, like, I mean, final solutions basically. Okay. In the final solution, basically beta 1 will be 1 by 10 theta 1 cap. I mean, this will this weight will adjust itself. Okay. This you do not need to adjust. So you can just adjust this. So B is the correct answer, because finally both will be giving you the same answer. So to match the same answer, because you are just modifying the linear feature, and if you are modifying the linear feature, weight will adjust by themselves, right? So B is the correct answer here. Now let's solve this question. This question is nice question in a way that the similar kind of question I have given previously, but there you were having W at both the places, right? But now you are having W1 and W2. See, earlier this model was not that good. I mean, this model was having some constant that, okay, the value of this particular expression, which means if you take x common, W square plus W. So this is not free to take any positive or any negative value. I mean, there is a minimum value for this W square plus W. But now you are having W1, W2. So these are the two independent weights, right? Now if you compare these two, then obviously this is a linear regression, and if you are having W1 square or something like this, then in this linear regression there is no point. This is still a linear regression, right? Because the features are linear. Okay, you focus on x. Okay, the features are linear. So if you are having W1 square, then you can immediately make W1 to be 0. I mean, the model will adjust in such a way it will not compromise. So it can make W1 to be 0 and W2 be same as whatever the W you are getting here, right? So that these both are matching, right? So that's why the both model will perform equally well on the both the data sets, on every data set, sorry. Understood? So in this question, this is W1, W2. So you can immediately set, I mean, you don't have to set it. The optimization method will automatically be setting it W1 to be 0. Now let's see this question. Okay, so in this question, basically, they are having this least square solution. They want to minimize with respect to beta. So earlier, like I used to have something like this: yi minus W transpose xi plus b, right? I mean, where the xi was the vector, but I think here this xi, the like this is basically like this xi yi. Okay, I mean x and y. So x and y are the vectors, but yeah, x1, y1, x2, y2. These are the here I think the scalars only. Okay, which is fine. I mean, we can easily do this question also. In fact, we have done this and we have gotten the final answer in the matrix and vector form also, right? I mean, the final answer here was W was coming out to be, I think, x transpose x inverse. So we have solved already these kind of questions. Yeah. So x transpose x inverse, x transpose by, right? So this is what, if you just minimize like this, you were getting. I mean, in the matrix form and these forms we have done it already, but now they are saying that can you do this in the scalar form also? Okay. So yeah. So in the scalar form, which means the xi's are the scalar here. So let's just quickly do it. Okay. So we can just differentiate this. This is the loss function. We can differentiate this with respect to beta. You will be getting, don't worry about the summation. Summation doesn't harm in the differentiation. This is 2 into something, right? 2 into beta of xi minus yi into xi, because xi is like beta into xi, so that's why you need to write into xi. Okay, you can write anywhere equal to 0, right? So from here you will be getting beta then xi square, right, equal to, this is xi by I, summation of xi by I, right? So xi square means that this is x transpose x. You can write as in the vector form if you want. This is x transpose x, because this is x1, you can say x1, x2, x3 multiplied by x1, x2, x3. That's how you are getting xi square, right? Summation of xi square. So you can write x transpose x here, and you can write x transpose by here. So basically beta is x transpose by divided by x transpose x. Okay. So this is your answer, x transpose by divided by x transpose x. So x transpose by divided by x transpose x, yeah, A is your correct answer here. Okay. So that's how you can solve this question. That's also a very easy question. So yeah, thank you everyone.